Good morning, good afternoon, everyone. Welcome to our webinar on connector materials for connectors in automotive. My name is Tom Rippinger, Marketing and Communications Manager for DSM Engineering Plastics in the Americas region, and I will be serving as your moderator today, facilitating the Q&A following the presentation. Please feel free throughout the presentation. If you take a look on the right-hand side of your screen, you'll find a box to ask questions. Please type in your questions throughout the presentation. We'll try to get to all of them. If we don't get to your question during the end, we will follow up with you via email following today's presentation. So now I'm going to go ahead and hand it over to today's presenters, Ted Wyzorek and Hans Hoekstra, to introduce themselves.
Hello, everybody. Thanks for attending today. I'm very excited to be with you. My name is Ted Wyzorek. I am the product manager here at DSM for the 4T product line and the Stenil product line. Our 4T product line is our PPA, high temperature nylon plastics product line. And the Stenil product line is our nylon 4/6 product line. We'll have about 20 minutes worth of content and leave time for 10 minutes worth of questions at the end. And I'll throw it to Hans for his introduction.
Hello, everybody. My name is Hans Hoekstra. Very happy to be here today with you in this webinar. I'm the Research and Technology Manager at DSM for our 4T product line based out of Geleen in the Netherlands. And in that function, I'm responsible for new developments that we do with our 4T product and new products that we make for the marketplace. And some of the products that will be discussed today basically were developed earlier within my group. Back to you, Ted.
Thanks, Hans. Well, what I've got for you today is a presentation and some data on reflow connectors and the thermoplastics used in reflow connector components that are actually attached to the printed circuit board. So with that, let's dive right in. So what is reflow soldering and why is it used in the industry? So reflow soldering, unlike the older traditional wave soldering, is a method of having the solder metallic material that will eventually adhere the part electrically to the circuit board. It's a method of having that on the device and on the circuit board before the part is mounted to the board. So essentially that solder reflows as it goes through a heating process to electrically connect the device, the connector or the surface mount device to the board. And the reason for that is that surface mount devices are much smaller. So unlike the old wave soldering process, the reflow process lends itself to these much tinier electronics. And of course, with the demand in both consumer devices and automotive going to much smaller boards, much smaller space, much lighter products, miniaturization electronics is important. The challenge that presents, of course, is now that connector that you've thermoplastic that you've molded needs to go through that heating process. So the metallic solder has to melt, but of course the device or connectors can't deform or melt as it goes through that heating process. So what kind of requirements are there on the plastics that are used on reflow connectors? The first one we talk about is JTech or chemical resistance performance. JTech is a way of rating how prone the material is to blistering as it sees the heat of the reflow process. And we'll talk about that in a minute. JTech MSL for moisture sensitivity level is the lowest rating is MSL level 1, which is the highest or best rating. In mechanical performance, the material has to withstand, keep its mechanical properties even under the heat of the reflow process. So you can't have significant melting or deformation. It's also a bit of a thermal shock to the material. As the material rapidly heats and then cools through the reflow process, the material is expanding and contracting. And that can cause cracks or defects to appear if the material is not robust enough to withstand that thermal shock process. The material has to have good weld line performance, which is weld line is where the melt in the injection molding process knits back together as it flows around open holes or cores in the injection molding process. And that weld line strength has to be maintained as well, so you don't start to have cracks or divisions at that weld line area. And then of course, dimensional stability is necessary because you don't want the parts to deform or warp or yield to any of the loads that they see in the reflow process. Color coding is another important facet. The color fastness of the parts has to be maintained as it goes through this heating process. Often thermoplastics can yellow or discolor or turn brown even as they get that as they see the heat of the reflow process. So you need good color fastness of the material so that the color of the connector can be easily recognized by the subsequent assembly operations. And then of course, the most basic is the electrical performance of the material. Obviously, these connectors have to be insulative. You don't want them to conduct necessarily. And they also have to have high CTI as power electronics become more used, especially in electrical vehicles. You need higher and higher resistance to tracking, and CTI gives you a measurement of how the material resists arcing across the surface between the conductors. So often we express this in volts. So you'll see that in a little bit. So let's talk a little bit about JTech MSL levels. On the left side, you can see the JTech ratings, 1 through 6, and 1 being the highest or best rating for blister resistance. And what that's giving you is many polyamides and many thermoplastics for that matter absorb moisture. They're hygroscopic. They want to absorb moisture even sitting in ambient conditions in the air, in your plant or in your warehouse. So as it absorbs that moisture, the material gains the moisture, and then actually when it goes through the reflow process, that moisture or any other volatiles want to boil out of the plastic. So if the plastic isn't robust enough to resist that relatively rapid moisture exit, or it absorbs too much moisture, you don't have good blistering performance. So what that means to you is, in a cost sense, parts that have a high 3 or 4 moisture sensitivity level rating need special packaging, or you have to use them in the reflow process very rapidly after molding. They can't sit on the shelf very long. If you do have an MSL level 1 material where you have a theoretically unlimited shelf life in ambient conditions, you don't need expensive packaging like foil line bags, and you can use much simpler and less expensive packaging if you have the JTech MSL level 1 rating on your parts. So the reflow soldering process, you can kind of see here, is a relatively rapid heating up to around 260 C for the parts. So we have to withstand both the heating and cooling stage and the time at that high temperature. The plastics have to be able to withstand that. So what are the kind of defects you may see in that process? Is blistering. Obviously, we talked about the MSL level. So that's a blister. This part obviously blistered through the reflow process. You can see cracking, especially around insert molded conductors, where the material hasn't been able to resist the expansion and contraction of that heating and cooling process. Discoloration can become an issue for the connectors as they go through the heat. And warp, where the material yields to any loads or stresses either internally or put on it by the assembly process. The material needs to resist that warp and deformation under that heat, and flat out melting, of course. You have to have a material that has a melting point well above that which it sees in the reflow process. So DSM offers several materials that fit into this space and have seen quite some success for both automotive connectors and non-automotive, for engine control unit headers, more high power lead frames that have to be attached to the board as well through the reflow process. Focker connectors, which we'll talk about in a little more detail. It's a coaxial connector for high-speed data, and various engine control unit products. So DSM has two product families for this reflow space. The first is the Stenil product line, the nylon 4-6. It's a straight chain molecule or polymer rather. So it has very good flow characteristics. So it is great for your applications where you have a wall thickness of less than 0.8 millimeters. So for very thin wall applications, Stenil is a great choice for your on printed circuit board connectors. Where you have a thicker wall stock, our 4T product line, our PPA, is a great choice. It actually has, if you follow down the material selection path, you can choose a V0 rated material. So V0 is a UL rating for flame retardants. So that tells you about the burning characteristics of it. If you do need a UL V0 material, our 4T T11 boasts great mechanics at high temperature. And if you don't need a flame retardant material, we have a variety of 4T materials all the way out to our 4T ACE JTX8 material, which is our best material for the blister resistance in the reflow soldering process. So it's one of the few materials that boasts a JTech MSL level 1 rating in any thickness wall stock. Let's explore a little bit the 4T family going forward in the reflow process. So as we said, the 4T ACE JTX8 material boasts the moisture sensitivity level 1 rating at all application thicknesses. So you can see that even at the temperatures of reflow, no propensity to blister, even up into 3.2 millimeter thicknesses. And best of all, or maybe better than that even, is it has that ability even with up to 50% regrind. Most companies want to use regrind for efficiency and cost, because you do have usually some runners and sprues that you need to utilize in order to keep the lowest cost. So even with 50% regrind, the JTX8 material boasts the MSL level 1 rating. So no special packaging needed, and theoretically unlimited shelf life for the molded component before it goes into the reflow process. The dimensional stability of our JTX8, our ACE JTX8 material is also quite appropriate for the reflow soldering process. It boasts low deformation at those kind of temperatures, and the one way to look at that or measure it is the heat distortion temperature. And the HDT is a rating of how the material moves under load and temperature. So you can see that the 4T JTX8 boasts a 320 C rating for the HDT, as opposed to some of the other PPAs that are out there that are much lesser heat resistance, and LCP even lower than that. And the issue there is if you do have loads on the part and they see that sort of temperature, they may be subject to permanent deformation or warping in the reflow soldering process. Another material, another grade that we have in the 4T family, as we mentioned, is T11. So our T11 material boasts an MSL level 2 rating at greater than 0.8 millimeters thick. But this is your flame retardant material. So if you do need the V0 flame retardant performance, 4T T11 may be a good candidate. It does have an MSL level 1 rating actually below 0.8 millimeters. So in thin parts, it is good for MSL level 1. In thicker parts, it's rated an MSL level 2 for blistering. And that's still better than most of the PPA family products out there. You can see zero tendency to blister as opposed to some of the today's PPA materials. We mentioned color as a requirement for the reflow process. So the color fastness is important. And if it is, 4T JTX8 has great colorability and great color fastness as it goes through the heating process. You can see even in a variety of different color palettes here, as these plaques were subjected to the heat similar to the reflow process, you can see very little or no change in color, even in the different color families. This is especially important in the newer automotive Focker connectors. These Focker connectors have a color coding scheme that dictates for the final assembly operation what lead gets plugged into which connector. So that it's important that the color fastness be appropriate so that someone can, for example, distinguish beige from curry color. And these colors are set in the Focker color coding standard. Thermal shock resistance, also important in the reflow soldering process, as we mentioned. As the part expands and contracts, you do not want it to exhibit cracking, even along knit lines that form when the part is molded. So these header connectors, you can see, are 4T T11 material. It's a 30% glass filled and the flame retardant version. Does not exhibit cracking even through that thermal cycling. Whereas some of today's PPAs actually do start to have cracks, especially at sharp corners and knit lines in going through the same temperature, heating and cooling cycle that you would see in a reflow soldering process. So for minimal thermal shock defects, 4T T11 can be a good candidate. CTI, comparative tracking index. I mentioned it a little bit earlier. CTI is a rating of how the material resists arcing across the electrical terminals that are in close proximity. And that arcing, it's a measure of resisting that arcing across the surface of the material. So especially with contaminants on the surface of a plastic like salts or moisture, you can have actually a short circuit or electric arc between closely spaced terminals. So as voltages increase, especially for electric vehicles, CTI becomes more and more important. Many are looking for very high CTI ratings so that there's no danger of arcing even at high voltages. The RT11 material boasts a CTI rating of greater than 800 volts, and that's really best in class in the industry for the family of materials that can survive the reflow soldering process. Just a quick example of a typical circuit board with its connectors. You see the header connector for the power connections, and these are all gone through the reflow soldering process to be electrically and mechanically mounted to the board. Some Focker connectors here. It's a coaxial connector. And so this is your thermoplastic encircling that connector, and some high-speed data connectors at the end. And you can kind of see here why, given that these are quite small, why you can't allow much deformation or any kind of cracking or any kind of defect or blistering in that connector, as then you wouldn't have a robust performance of the connector. So just to recap, our 4T T11 material is your choice for V0 performance. So if you need V0 performance, it boasts a JTech MSL level for low blistering, level 2. It's good for reflow processes up to 280 degrees C. Has good robust performance for both industrial and automotive connectors, and CTI over 800 volts. And for best in class, moisture sensitivity level resistance, so unlimited shelf life and low blistering as it goes through the reflow process, we have the JTech MSL level 1 rated JTX8 material. It has a good combination of mechanical robustness, modulus, and strength, and great colorability and ability to retain that color through the reflow process, and operates with a good high continuous use temperature, we call it, without heat stabilizers. So that's the material family for the reflow soldering process. Like to take any questions you have open it back up to Tom, and he'll take your questions through the chat window, I believe.
Thanks,
Tom?
Ted. Already got a few questions from the audience. So the first one that we have here, is it correct that an MSL2 material means that I need to dry pack the part?
I don't know if I don't know if there's a definite answer to that, but it's much more likely that you'll have to dry pack the part than one without than one with an MSL level 1 rating. If we come back, I'm going to go back to the slide really quickly because I think it'll help a bit. The JTech MSL testing was designed a bit to try and tell you how long you can leave the material in a room temperature environment, and I think the room temperature and humidity environment, which I think they rate at 23°C and 50% relative humidity. But you can see that a level 1 part sort of has an unlimited, theoretically at least, unlimited shelf life, whereas a level 2 can only sit for about a year in the open ambient air. So it's possible, depending on the conditions where the parts are made, if you're in a hot and humid area, it's much more likely it'll absorb moisture than a cool and dry area. But it's much more likely with a level 2 material, you will have to dry pack the parts than a level 1. Back
Thanks,
to you,
Ted.
Tom.
Yep, got a 3-part question here about 4T11. So the first part, what is the CTI? The second part of the question, is it a halogenated flame retardant? And the third part, is it glass reinforced?
It is glass reinforced, so 30% glass reinforced, T11. It has a CTI of greater than 800 volts. You may know, the questioner may know, the original ratings for CTI weren't designed to go quite so high. So it could well be that it actually is considerably greater than 800 volts, but that's the highest we've been able to test so far. So it does go greater than 800 volts. And then the last part of the question, the flame retardant, it is not a halogen-free flame retardant in the T11 material. I'm sorry. I double negative that. Hans, you want to help me out with
exactly.
that? It is a halogen-free material. Sorry, go ahead. Go ahead, Hans.
Oh yeah, that's, I wanted to mention that it is a halogen-free material, and the CTI voltages we've tested actually a bit higher. We cannot go higher than 1000 volts. The conventional testing usually is up to 600 volts. We at DSM went testing to higher voltages. Most of the norms, actually all of the norms currently only require 600 volts, but you see trends towards industry asking for higher CTI capability. So we went up to testing up to 1000 volts. And indeed, the T11 robustly passes 800 volts, and we've measured it up to approximately 875 volts. But we feel comfortable claiming that it will do always at least 800 volts, because always with the CTI measurements, there is a plus or minus on those measurements, of course, but it will always do more than 800 volts.
Thanks. I have another one here. What is the strain at break on T11 material?
Hans, I think I'll have to flip that one to you.
The room temperature strain at break is about 2.1, 2.2% elongation at break. That is measured at the conventional tensile bar thickness. At lower thickness, it will do 0.1 or 0.2% of an elongation more.
Great. Here's another one. What are the processing considerations when molding 4T11? Any issues when molding it?
Like any high temperature material, so PPA is a high temperature polyamide, and like any high temperature plastic, because it withstands high temperature when you mold it into a part, it has to be processed and molded at quite high temperature. So what you do see at those high temperatures is a tendency to, well, first you have to keep your machines at higher temperature, so that's a consideration if you're molding regular nylon 6 today. But it also can lead to, and because it is glass filled as well, it can lead to more screw and barrel corrosion than low temperature materials. Because you're operating at now a high temperature in your injection molding equipment, if you do have, you especially need to take care of to not have moisture in the material because that exacerbates the corrosion problem. But you do have a glass-filled material that's molding at very high temperature, and then that glass continues to scrub any corrosion from your screw and barrel, which can result in wear. So low residence times are important. Low moisture is important. But like any high temperature material, it's a little bit more difficult to mold than a lower temperature material. If processing is a big concern, we might point into the direction of our Stenil material family, which is the first material family I presented, because though that's a high temperature material, the molding is much more friendly and acts much more like a typical nylon 6 or 6.6 material in the molding process.
Maybe one point to add here from my side. Because it's a relatively high TG product, the T11, it's advisable for having maximum mechanical performance to mold this at oil heated equipment, so that your mold temperature can go towards 130 degrees C, because if you go to lower temperature, then you will not get the maximum mechanical performance out of the product. And as Ted mentioned, corrosion is a point of attention with these high temperature processing materials. They can be processed on conventional injection molding equipment, but because of its flame retardant, it has some corrosiveness due to the flame retardant, and you need to take some care in selecting the right quality steel, especially for your screw designs, because if you use too low quality steel, that can be an issue. DSM has quite some experience there, so if needed, we can always advise you on how to select the correct types of steels for molding this type of material.
Thank you, Hans. Actually, I had one other thing was, Hans is absolutely correct. You do want to have for best performance a high temperature mold, which means oil heating. Also very common though is pressurized water heating. So if you do have pressurized water or oil heated molds, that's appropriate for the 4T family.
There's a quick follow-up question from the same person that was asking about processing. He asks, are there any special considerations when molding the halogen-free FRT11?
Yeah, I think that's a bit what Hans was talking about, because and this is true of any high temperature material family out there with a halogen-free flame retardant, though we're continuously working on better solutions. It is true that the combination of high temperature, halogen-free flame retardant, and the glass creates a corrosion and scrubbing action on the injection molding equipment that causes some degree of wear. The solution to that really hasn't been found yet by the industry. The best we can offer today is you want to mold at very low moisture conditions. So we do recommend you, even though we ship the material dry, that the material be well dried before going into the mold, that the residence times be low, and that the screw and barrel be purged immediately if the machine were to stop for any reason, for breaks or shutdowns.
Great. Have another one here. Did you show on the slide that T11 material can fulfill MSL1 or MSL2 depending on the material thickness?
Let me run back to the slide quickly. Oops, sorry, went the wrong way. Sorry, maybe I should just do it without the slide. Essentially, the material, the T11 material is MSL1. The MSL level is actually rated in parts, so it's not really the material itself necessarily, it's parts made of that material. So in parts made of the T11 material that have wall thickness below 0.8, it is a JTech MSL level 1. If you go thicker than that, because the material absorbs moisture into its core, and then the moisture has to come out of that core, then it is only a JTech MSL level 2 material.
Okay. You have another one. Okay. He responded to us that answered his question.
Okay.
Do you have a humidity absorption over time curve for the materials you have in your presentation?
Sure, absolutely. We even have some. We definitely have even a calculator for the Stenil family, and we definitely have some absorption curves for the 4T family. You can even find just in quick data, it's not multi-point data, but some quick data on our data sheet side. You can easily see the moisture absorption amounts, both at ambient maximum absorption and at a water immersion absorption right on the data sheets themselves.
It might help answer the next person's question. He asks short-term and long-term working temperature and duration.
So JTX8, I'll go back to this slide, has that would be what we would call like a continuous use temperature. So that involves a few things. It's heat aging, as well as resistance or good mechanical properties at that temperature. Hans, maybe you can talk to the exact numbers for continuous use temperature for the JTX8 and T11 material.
The exact numbers depend a little bit on what lifetime you define. Usually you would take 3,000 hours, but sometimes you take 5,000 or even 20,000 hours. All these numbers are on our data sheet. I don't know all of them by heart, basically, but if you pose the question more specific, what you're looking at will help you with that number. The other one on lifetime that's also worth mentioning, maybe that's also what is meant, is the RTI values of these materials. And that's then either electrical withstand, basically. The T11 is RTI rated 140 degrees C for the electrical performance, and depending on the thickness of mechanics and mechanics with impact, it can be either 140 or 130. But also those, they're available throughout the yellow cards, basically. And if you detail the question a bit more specific, we can come back to you with the exact data on what the lifetime is at a certain temperature.
Yeah, absolutely. And I'd like to add to that too, if you'd like to contact me on any of these specific questions after the presentation, either by email or on the phone, we'd be happy to answer in specifics.
Right, so that's a good segue, Ted. So that was all the questions that have been submitted so far have been answered. I'll send both of you, Hans and Ted, a list of everyone that asked questions, and we'll be sure to follow up with each of you via email just to make sure that we answered your question adequately. Everyone who attended today's webinar will also get an automated follow-up email with a recording of the presentation, and you can also reply to that email if you have any questions. So there'll be details on how to submit them. But thanks everyone so much for taking the time today to attend our webinar. Appreciate you taking the time. You also might notice I attached a handout with details about other upcoming webinars and our Advanced Materials Forum Europe, which will be a full day online event coming up on April 23rd. That's attached in the handout that's available for download within the GoToWebinar tool. And we'll also send around the details in the follow-up email tomorrow. Again, thanks for attending, and hope everyone has a wonderful day.
Thanks, everyone. Thanks, Tom.
Thank you, everybody.